In this video, I'm going to introduce you to the idea of a radian measure as opposed to a degree measure to label an angle. So we're going to be looking at first at arc length and comparing the arc length to what the radian measure really is. We're looking at a circle with a radius of 1. We're going to find the length of each arc subtended by the following angles, just meaning that it intersects those angles. We're going to draw each angle, and then we're going to use a proportion to solve for this. So just remember, when we're doing our proportion, we're going to be doing part over whole and setting those two equal to each other to get a proportion that we can then solve for. So we're going to start with 30 degrees. If we were to draw that angle, which we did in our last lesson, 30 degrees would be about here. And I'm just going to label this point A and point B because we're going to be finding this arc length right here. So since this is 30, and this has a radius of 1, we're going to be talking about the circumference to find the arc length. So if we think of circumference as 2 pi r, our circumference actually for all of the problems on this front page will be 2 pi times 1, or just 2 pi. So what I'm going to do is parts over whole. I have 30 degrees out of a full 360, because if you think about going around the entire circle, that's our 360 degrees right there. And then we're looking for the arc length AB over 2 pi. Since 2 pi is the entire circumference, that's going to match up with the 360 degrees. If we cross multiply and solve that, now I'm going to show you in the calculator, we can kind of do that all in one shot. So if we do 2 times 30, I'm not going to multiply by pi, I'll keep it in terms of pi, and then divided by 360. We get 0.1666 repeating. I'm going to put that back into a fraction form to get us 1/6. So really, we didn't multiply by the pi, so that's going to give us AB is equal to pi over 6, because we should have multiplied the 2 pi in there. And that proportion is essentially what we're going to be doing when we go to find radian measures later on, but this is kind of a good intro to what we're doing with that, and also a good refresher on drawing angles. So we're going to do the same thing for 225. I'm going to start with A. 225, if we go around here, 0, 90, 180, 270. So 225 is right smack in the middle of the 180 and the 270. We're going around all the way. So the arc measure is 225. We'll call this B. Since it's larger than 180, I'm going to give it another letter in there, if you remember back from geometry, to label that, because AB would actually be the shorter distance from here to here, and we don't want that. We want the whole distance around the 225. Our process is going to be setting it up the same way, so we'll do 225 over 360 is equal to ACB over 2 pi. So that 2 pi and the 360 are staying constant, and really all we're changing is our degree measure up top here. So our arc measure for ACB, arc length, I'm sorry, is going to be, again, let's do it all in one shot. So we'll do 2 times 225. So the pi would be going with that numerator, and then divided by 360. Again, we want to put that in fraction form. So I'll hit math, enter, enter. Or you can use the fraction tool to begin with if you want it to come out to be a fraction every single time. So we again get 5, and then we just want to throw pi with that. So 5 pi over 4 is going to be our arc length for that one. We'll just do 2 more. And then we'll talk about how this matches up with the definition of the radian. So 120 degrees, 0, 90, 180. So a little more than 90, closer to 90 than it is to 180. So I'll draw that terminal side closer to there. And then because it is smaller than 180, we'll just write AB. And we'll set up our proportion. 120 divided by 360 is equal to AB over 2 pi. So just if you wanted to do alpha y equals instead, we could do that. And it will keep it in the fraction for us. You just don't want to put in pi because then it will just give you the irrational number. So we just assume that pi is part of that numerator, since we know we were multiplying that up into the top. So our arc length for this is 2 pi over 3. And then our last one, 285, if we want to see where to draw that. Part of this is getting a little more practice of drawing our angles. So 285 is a little bit more than the 270. We'll put it right here. And because this is bigger than 180, again, we need the middle value. I could do it as ABC. I'm not sure why I'm putting the C in the middle. It doesn't really matter. So we'll do 285 over 360 equals ACB over 2 pi. So this whole angle here rather than the smaller angle. I'll do the alpha y equals just for a second time. 2 times 285. The pi should be up there, so we'll put that in on our final answer. Divide by 360. And we get 19 pi over 12. The first 3 angles that I gave you will be angles you'll be using a lot in your trig class. This one won't be as common, but you'll use it when you're trying to just convert back and forth from degrees to radians when we start to look at that. All right, so this leads us into what is a radian. If you let the vertex of the angle be at the origin with one side of the angle on the positive x-axis, again, that's our standard position. One radian, or the radian measure, so 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. Meaning it is the same as the radius. So the important thing is in a unit circle, that has a radius of 1. So the radian measure is actually equal to the arc length. So what we want to think about to connect to what we were just doing is 1 revolution around our circle in degrees is 360 and 1 revolution around the circle in radians is 2 pi radians. Again, the circle we were using was actually considered what's called a unit circle that has a radius of 1. Because remember, if we do c is equal to 2 pi r, that's our circumference, and r is equal to 1, the full revolution around the circle will end up being 2 pi. So if we simplify this down, if 360 degrees is equal to 2 pi radians, we can divide that out by 2 and get that 180 degrees is equal to pi radians. So in our next video, we're going to start the process of converting radians to degrees, and then looking at how we can divide up our circle with some special angles.